So let's answer this kind of weird question that we tried to do a quiz to enlighten ourselves on. So I want to know, in chapter 4, number 47, why does a matrix have to be square to have an inverse? I paraphrased a little bit. It said that I should consider systems of equations to figure this out. So over here I wrote down some systems of equations for not square matrices, right?
Oh, yes.
So I remember that when I'm looking at one of these matrix equations, right, I've got A that's rows by columns. And I'm multiplying that by some vector x, and here I'm just denoting a vector of variables with a little vector hat. And this is supposed to be some answer. Don't sweat this notation too much. Here I just mean a vector. Here I mean a vector. I'm just too lazy to write out the whole thing. Okay, see that? Specifically because I have no idea how long they are, right? Let's go with that. Okay, so I have some equation, or some matrix equation like this. When I look at this thing, I realized a minute ago that I might think about this rows by columns business as what? How was I thinking about that?
Systems of equations.
Yeah, that if I turn that into a system of equation, that's the number of equations by number of variables. You guys see that? So I know that for a system of equations to be kind of reasonable, right, these two things should match. You guys remember that from someplace?
I don't remember that from someplace.
Okay. So if these two things match, what do I know about the matrix?
It's square.
It's square. You guys see that?
They have to match.
So I'm wondering, why does a matrix have to be square to be invertible? And I'm thinking maybe it has to do with the number of equations having to match the number of variables. You guys see that? And then I might go think, okay, what if I had more equations than I had variables? Like, here's one. X is 1, x is 2. I have one variable, yeah? And how many equations? 2. What can happen in this case? Yeah, I mean, this just doesn't work, right? X can't be both 1 and 2. That would be crazy. You guys see that? So this case, right, where I had more equations than variables can yield what? What do you call this system? Anybody know?
Pathological.
Yeah, this is called an overdetermined system.
He's just trying to write it up fine.
Yeah, it's good. So I've said too many things about x, right? You guys see that? That's what overdetermined means. I've forced too many things to happen. What if I have more variables than equations?
Underdetermined.
Good. That would be underdetermined.
It's not solvable.
Yeah, I mean, kind of what's going on there. Like, here's an example. X plus y is 0. Right? How many solutions does this thing have? Infinite numbers, right? Specifically, this thing is really the line y is minus x, right? You guys see that? There's a lot of points on that graph. Cool. So that's one thought, right? It has to be square to be invertible, right? Invertible really, in this case, is a byword for this system has a solution. You guys see that? If the matrix is invertible, I can just hit both sides with the inverse, and I'll get x equals whatever the answer is. You guys see that? So here, invertible really means the same thing as this system has a solution. And this system has a solution only when it's not over or under determined, right? That's a kind of a Goldilocks thing, right? Which is really when it's square. You guys see that? Do you want to see the spatial reasoning that's a little bit more confusing? Okay, spatial reasoning.